Hi, this is a quick tutorial or explanation of what is useful as an educator about this KISS library, which I am trying to promote. Um, Again, from the point of view of an educator, so the library is available at this address, so github.com/wmcavoy, that's me. I'm a professor of computer science at Colorado Mesa University in Grand Junction, Colorado. I've been a teacher for 20 years now, and I was watching some young students learning the Java programming language without such a tool this summer, and this was an itch I had to scratch after seeing what was going on. So this is not an introduction for people trying to learn the programming language. I'm going to talk about a lot of concepts that that don't really mean anything to a beginner, but to an educator, I think, who's comfortable with the language, it should mean quite a lot. So let me get started. So over on this side, this is the classic hello world, using just the classic infrastructure of the language. And then on this side is I'll say the better version from the point of view of this discussion. So let me try to compare the two. So over on this side, there's a few cosmetic differences that let me just get out of the way. So here there's a package declaration, and on this side there is no package declaration. So it is actually quite simple to have a package and any class be the entry point for a KISS style application, but the default is have no package and to always have app as the name. And it's one of these simplify your life points. It's actually very simple to change. Just you have to specify a command line argument in your run to get it to pick a different one out. But for a beginner who doesn't care, and for every C programmer who knows it's always just called main, just having a convention for where everything starts doesn't seem like that big of a deal. Okay, so there's one cosmetic difference. The next one that you see as you go down is this one requires an import statement, while that one does not. So that is certainly a bit more complicated of one side compared to the other. But anybody that uses Java will have to agree that import statements are so fundamental to getting almost anything to work that you have to introduce the concept pretty quickly, and so there's no real loss of, well, okay, so you want to introduce something and that almost instantly is necessary for every bit of code they're about to write. I don't see why that's a harmful thing compared to over here you don't have to say it. All right, but here the next step is this public versus not anything on this side. So it's optional. You can make it public or private. The KISS libraries uses reflection, and so therefore ignores or is written to ignore the accessors on this side. So I'll point out that that's just generally true. So you should be aware that these are just hints anyways. So any software could use reflection to access any package they really like, and modify fields that are private or final and that sort of stuff. So really, it's a hint in the Java runtime, as opposed to an enforcement. Now they are useful concepts, but as far as limiting how many concepts you really need to know to get started with an application, I think fewer is better. And while importing packages in order to use them, I think is pretty easy to say, discussing all the public-private business and packages just to get started with an application, I'm not sure is that necessary, because you're not going to need that right away. So then the next thing you notice as a difference in here is really the signature, the complicated signature that happens for how you do the entry over here in the traditional setup, versus just you make a run method and that's it. So on this side, the thing that to me creates in the long run the biggest problem is just the fact that no instances of this class are made unless you do it yourself, and of course that may or may not happen depending on how you introduce the language. But it does create a kind of a giant rabbit hole of new technical terms before anything really happens over in the Java world for a beginner to try to understand what static means and what instantiation means, which creates a lot of barrier to understanding, I think, of the whole mechanism. So on this side, an instance of the main class effectively is created for you, and then using reflection, so you don't have to implement any interfaces or anything like that, the run method is discovered and run. So you get a constructor. That's essentially, you could create more complicated instances if you need to, and at some point that's a very useful concept to introduce, and so there's nothing wrong with introducing it when you want to, but you don't have to right away. They're made, and you don't have to worry about it, at least for the beginner. And of course, you can get values without worrying too much about what is a static versus a non-static method, and there's nothing surprising about what happens, right? So on this side, you just get the things that you want, and over here, if you want to do that sort of stuff, you suddenly find yourself talking about static versus non-static members and instantiation and that sort of stuff. So you do eventually have to make those distinctions and get everybody to understand how they work, but kind of that detailed discussion about something when someone's just learning how something works is not useful. It shuts people down and makes them all confused, and I've seen it in students when they're trying to learn this sort of stuff. Even sort of fairly adult students in advanced classes would rather not have to think about that right to start with. All right, so yeah, I think static is a huge rabbit hole for how programs get run in a typical setup, and that is just totally unfortunate. I think it creates a lot of confusion. So then the next thing, which bothers me, I guess, a lot about this version over here is testing. So if you wanted to test this Hello World program, even if you're familiar with tools like JUnit, just how much would you have to explain to a student to understand how in the world would you actually test that this thing is generating Hello World? So let's test this one and see how it works. So I guess we'll start with exactly the Hello World in this case, right? And so to write a test, you write test and the thing you want to test. And again, through reflection, it just finds all the test methods and invokes them before it invokes run. And so it's just writing a method, and the IDEs understand how to do that. So I guess the other important thing, this is not any extension to the languages. It's obviously strictly just the library. So students can use this forever, but eventually they will move on, I'm sure, to things like JUnit and things like that. But it creates a pretty simple and easy to understand test framework to get everybody started with testing their code. You can create tests and then leave the code part empty so that they can actually really start out with test-driven design, which seems like a great idea. And because of the framework, the way it is written, it's actually quite easy to get started with. So let's see here. So I could it's output. So out expect hello world, like that. Call the method where that output is expected, and then close it. So now if I run this one, oh, hi, man. That's the value of test, right? Okay, so here's my test run. I expect to see hi world come out of it. I run it, and then I close it. So again, no long discussions about how to create a test. This is what you expect as output from this thing, and let's go ahead and make it a little more complicated. So int x equals 1, like that, and then print hi world. So and then print hi world will have a second line, println x equals plus x down there, and so now we expect two things. So if it's pretty simple, then now this is what we expect. Hi world with an end line because the println thing, I think that's not that hard to explain. And then the output of this thing should be x equals 1. And if I run that, oh look, it still passes the test. And then the output that you actually see on the console down here happens when run is invoked after passing the test. So the run method here, the output is redirected to an internal stream, and that stream is verified against this stream while it's run. So you can have it verify against external files and that sort of stuff. I was just trying to write kind of the least I could using the framework to do the test. So testing this hello world, which on this side I think most people wouldn't even attempt, on this side is actually very easy, and I think that's actually a huge win in the framework, and that's actually one of the big goals I had when I was building it up. Is I wanted it so that students could quickly get their heads around and start using some effective testing methodologies. And of course there's many methodologies available to you, but right now just the fact that you can do it without a lot of discussion, and you can do it to the sort of things that you'd introduce them to anyways. So you don't have to ask the students to reframe what they're writing and still have access to some sort of test mechanism. I think that's really important. The runtime environment automatically enables the assert mechanism that is built into the Java language. I think that's a really nice feature because it doesn't make students learn a whole new syntax for how asserts work. So in here, I can just have a void test math, and even though it's a double, I believe this will work out exactly. So I can assert that the square root of 4 is in fact equal to 2, and I guess we'll just find out. Check that. Oh yes, it is actually exactly equal to 2. So even though that's not it is a double precision math question, since it's working with IEEE. You get exactly 2 out of that square root question, and the assert notation works just fine. It's compatible with all the IDEs, and notice I just had to write the test, and oh look, it runs a test right away, which is nice. I think this is a fantastically important part of why I wrote the KISS framework the way it is. So it's easy to write tests, it's easy to run things, to create some output. You don't have to have a run at all. So by the way, so actually let's just get rid of how much do I want to get rid of? The thing is I'm going to change this to high. Okay, so I'm done with that. By the way, okay, here's the next big advantage that I see when people are trying to use this IDE or use an IDE to illustrate concepts. What I see a lot is you kind of have two options. You can create new projects every time you want to introduce a new concept, and then those concepts hopefully will stay as little snippets of ideas that the students can come back to. Because there'll be issues in trying to create those new projects each time students try to walk through that. I've seen this with students. What usually happens instead is they'll just wipe out what they had before and start trying to build up the next sort of concept, and they really won't have that log of what was going on. Now in this case, because all of these little methods are just in here, it's actually quite easy, just as I did. So here's an example of the testing, and now I guess I should rename that one test high. And now it just exists as a living little example of some features of the language, and of course they're all executed as I go along, so the syntax of this won't get lost. If I want to move on to a new concept again for a beginner, I just have to create a new method, I don't notice, by the way, there's no longer a run method. That is perfectly fine. There's nothing wrong with writing a class where, in fact, the entire goal is to pass all the tests, right? That is test-driven design. So you can start really talking about what that means. And the students, as you have different concepts tested and implemented inside of little test blocks or methods that those test blocks call, they can have a log of what's been going on and keep that as not a bunch of code that almost works, but because it's being tested as you're using it, in fact, always just as a working example that they can go back to and use without having to hunt too hard or having a lot of projects, which what I see is students don't. And in the end, they end up losing track of, oh yeah, we did talk about that, and I remember building an example, but now that example is long gone. I don't have that anymore. So of course, you can create whatever level of infrastructure you want in here, but again, you don't have to. And that does mean that when you're trying to teach those basic concepts to get started, they can have a nice kind of log of everything using the notation and language just put in place. A little words about the println, right? So over here on this side, obviously we're using instances of the console here, which wires us into something that might be harder to test, right? Because we are, in this case, it's just console output. So what this thing does is uses thread local variables and a stack of streams, so that as you open streams, it uses the top level stream in the current thread. So it's a thread safe solution to this mechanism without having to decorate and pepper everything with lots of method names. It is a very safe mechanism and a nice convenient shorthand version of how to do this. I'll say from a long-term implementation issue, Java's implementation of thread local variables is deadly slow compared to C's version. And I'll just call that unfortunate. I don't know why or how they made something as slow as it is. So if you have lots and lots of output, it will be somewhat slower than doing the output using the console style. But everyone here then has heard the problem of premature optimization. The speed advantage you get out of handling, going directly to handles that might or might not be thread local, just doesn't matter to almost all applications when you're just doing a little bit of console output. So just let it be and don't worry about it. Eventually, if speed matters, well, then that's an optimization you can start to talk about. And of course, if the output structure is more complicated, then you can start introducing the streams and introduce the complexity sort of as needed, as opposed to having to discuss that complexity up front. So I guess the next thing that might curl a few toes, right here. So let's create an output file. So void. Let's put our hi into a log file. So let's call this log hi, a little function, of course, and out open my log. I guess hi.log, maybe something like that. Then call hi, and then out close. So because they nest just fine, so I can call this, and the output of this will be redirected into the hi.log, and then after that it'll close. Notice there's no need to discuss exceptions and that sort of stuff. To just create a little log file and use it. You're not introducing a bunch of new syntax. Now, if you want to use some of the more modern methods and assure that the output file is in fact correctly closed, you can also I'll call it kind of do the right thing and use a try block like that, and it is more typing than the other version, and it does involve introducing an important concept, and it works just fine. So now this one, notice you don't have to really refer to log anymore. It still uses the thread local stack of streams to figure out where to send things. But now log is guaranteed to be closed, and that's what most people want. And so now you can just have a try with resources block that will just close, and now that's a that's a safer, more modern version of how to do that, and it's easy to introduce, and it just works, which is nice. So we have the okay. I guess there's the next little mechanism. So math. Notice it's not math dot square root. I don't. Maybe this is a peeve of mine, but any significantly long formula just gets really hard to read with all the math dot business in there. So I just got rid of it. So when you import the KISS library, you effectively import the math library, and so you just get those things for you, no problem. Okay, last bit, I believe this is the last bit, and that's got to do with randomness. So the standard Java library for someone who's not good at math is just confusing and poor. Like the randomness source is poor. So someone who say in an elementary class, I think it'd be a nice programming project to say ask them to write a program that generates a password. But if you think about what that means, it suddenly turns into a senior project, right? If you just ask someone to write a password, and for them to really understand what that means to write a secure password generator, and it comes down to understanding randomness in the system. And the reason is the randomness, the random number generator that you just got to get out of math, for example, is a very poor random number generator. And so the next thing that the KISS library tries to fix is just make it easy for everyone. It is a little slower. I'll say it's about half the speed of the normal random number generation, but it still is it's in the hundreds of millions of bytes per second on my 2-core little laptop over here. So it generates plenty of randomness, but it's better. So if I say void, how about let's just throw 6 dice. So void test dice and dice. Let's call dice a few times, and then our method void dice, just println roll, and then random 1 through 6, like that. So that's really what people are looking for. So if you want a random number, you want it from a beginning to an end. This is a strong random number generator. It's created using AES counter mode PRNG. AES is highly optimized on most modern chipsets, so it actually is very fast. So if you use just the standard secure random tool, because the SHA is actually fairly slow, it's just not as fast, but the random method that comes out of this one is actually very fast. In fact, that's a more detailed thing. You can go look at the AES PRNG library in the system and use it for other tools. I think it's a pretty good implementation. But for the beginning user, what they really want is they want random, and when they want random, it's the random that you think of. It's random, and so let's just run that. So 6. So when the test dice is run down here, there it is, 2, 1, 3, and if I run it again, 2, 1, 3 again. So this is my first, I guess my second point. So when you're running tests, it is a pseudo random number generator. It is cryptographically strong, but at the beginning of each test, before test dice is called, for example, it is reseeded to seed of 1 so that you have reproducible results in your tests. And that, again, I think is a big deal. It helps students actually discover what went wrong, especially when they're trying different versions of the program. If it breaks, you want repeatability in your tests. But if I then run it from here, and just to make sure well, it'll be obvious that that came from there. So we'll run it again. Oh, what did I do there? Oh, too many closed bracket things. IDs can be nice. F6. Okay. So the roles that happened up here was obviously inside of this test types business. Down after it passes all the tests, here's the roles 2, 2, 3, 4. But if I run it again, F6, 4, 6, 4, 4. So these roles do vary, and the reason they vary is not just because of the way it was seeded with time or something like that. It's seeded with basically 128 bits of strong random number source. It uses dev random, so it's it's a non-blocking source, but that's still a quite strong source of randomness on modern systems. And if it can't get it out of there, so if you're running Windows, it uses the secure random tool to get randomness. So the combination of those two things ensures a strong random source on essentially every device that's out there. And so now you can very legitimately write or ask students to write, well, obviously things that use randomness, but you can also include the sorts of things that I think the students might find interesting, like a password generator that would generate passwords with certain patterns. And you can sit there and know that, in fact, they work. Well, when they run, they're creating cryptographically strong passwords. You're not creating some sort of tool that in the end is actually broken and they have to go find and fix it somehow later. It just works, and that's the point of keeping it simple. So so the randomness is one of those things that's hard to fix, like do very well without some support in Java. And so the KISS libraries provides that, hopefully in a way that is easy to use. You can create tests around if you need to. It has just two methods in there, random 1 through 6 or random, and you can use the entire range. So if you want a full-on random number, you can use integer max value here and integer min value there, and it will just give you a random integer. So that works just fine. And of course, if you want if you don't pass any arguments, you get a random number between 0 and 1, inclusive of 0 and exclusive of 1. And so if you're trying to get those kinds of random numbers, those are also pretty easy to get to for experiments. So in the end, those are the sort of random numbers that people want. And so rather than having to talk about modulus and doing arithmetic using the mod operator and multiplying and rounding and that sort of stuff, which is just magic to, say, a high school student trying to understand how to write a program, this is just much better, and they can go on and start hopefully thinking about and solving the problems that they find a little more interesting than worrying about how do you get a die roll. It should not be hard, and with this setup, it is not. So that's about it. I think it is simple. I mean, that is the point. It's not a whole lot of code, but it has good intention. So the idea is to get things started in a direction that is really helpful to the beginner and allow you to introduce the concepts at a pace and in an order that is useful to you as an instructor, and for them to get a handle and a joy out of getting things to work without too much complexity just to get started. And all that complexity makes things hard and makes people's minds want to not really understand what's going on. So that's it. I hope you think it's a good idea, and I'd love a little bit of feedback on features or changes, or sets of test-driven homework assignments, so that it's a fill in the blank. That'll be really, really great to know about. Thanks for your time.